sum up all the batteries which makes a battery pack, and through this battery they supplies the energy to the engine, and but supply the energy to the motor, and with the help of motor these wheels are rotated and the power is and the vehicle moves like this. So basically an electric vehicle is a, we can say, a more advanced version of the fossil fuels vehicles which reduce the environmental impact on the earth. So this is a broad architecture that how basically an electrical vehicle uh, how electrical vehicles like works. So there are various types of electrical vehicles like pure electrical vehicle, hybrid electrical vehicle, in which plug-in hybrid electric vehicle. So just to understand, to have an overview of broadly how does it work. So there is a brain which we say that it electric vehicle have is a battery pack, and this is the brain of this. If it doesn't work, the vehicle will not operate efficiently, it will not operate only. So battery pack is one of the major main part of the electrical vehicle, and through this battery pack the current is supplied to the inverter, which basically converts the DC supply from the battery pack to the AC in the motor, because motor runs on the AC supply. So inverters help is to convert from DC to AC. So from the, and here BMS also plays a major role. What it do? It basically control the and regulates the flow of the current or the voltage which is required in the output of the battery, output of the battery pack. So after this inverter, the current is transferred to the motor, and through the motor this motor output shaft is connected to the transmission system, which further transfer the power to the wheel, and this is how the electric vehicle works. And now our main concern is that electric vehicles are working on a battery pack. So battery packs, when it generates it generate power, so power generation is doing in the battery, and meanwhile internal heat generation is also occurring in the battery. So how to overcome this internal heat generation? Because battery consists of cells, a pack. Those cells, if the temperature is more and if we will not be, it will dissipate this heat, so what will happen? The battery function will be improper, and the life cycle will also be reduced. So the one thing is that nowadays what are, the batteries are facing challenges in the electric vehicle. So what are these challenges? Before that, I want to tell you that the batteries now in electrical vehicles, there are various type of batteries available in the market, like lead acid battery, nickel metal hydride battery, lithium ion battery, nickel cadmium battery. But lithium are batteries are majorly used in various vehicles. Why? Because it have long life cycle, high energy density, low maintenance, and also have a low self discharging rate comparative to the other batteries. So these batteries are are mostly used nowadays. But having the advantage, lithium ion battery have a disadvantage also, and that is an internal heat generation. This is one of the major disadvantage that the lithium ion batteries have. So researchers and experimentalists are working on this, that the internal heat generation which is developing in the battery, which cause rise in the temperature, how to overcome this. So these are the major challenges. Like long charging time is also one of the challenge which we are automobile industries are facing, and overheating is also one of the factor. And because of this overheating, the life cycle of the battery is reducing, and short circuit is one of the main reason. And since we know that the battery cost total electric vehicle cost in that battery cost is very high. That's why nowadays electric vehicle are more costly because of the battery cost. So Before going to the BTMS, we should be understanding that how this temperature is affecting the battery. At what temperature range is optimum, which give the maximum life cycle, and above that optimum range, what affects adversely affect the battery performance. If we are going below the that optimum range, then at that temperature, how that temperature affects the battery performance. So this is an optimum range which has been found, like 15 degree to 35 degree is the optimum range. Some of the research papers and 20 to 40 is also given. So this is an optimum range where battery approaches a large life cycles, and the performance is also very high. So if we go below the optimum temperature, let's say below 15 degree, if our battery pack is there, or above 35, we can take above 40 to 45 degree, then the battery life cycle is reduced. So at low temperature, when a battery is at low temperature, what happens that the internal heat generation within the battery and the ionic conductivity reduces, because the viscosity of the electrolyte is also increased when the temperature is very low, and which in further cause the power and energy output less, decrease the power and the energy output. Especially in the cold climate, it is very important to heat the battery to an optimum range so that we can get an optimum output. And other issues are also there, like in a lower temperature, the electrode surface, there is a formation of dendrites. In a lithium, in the lithium electrodes, there is a dendrites cracks, small cracks occurs, which basically cause reduce the life cycle of the battery. Again, if suppose we increase the temperature of the battery from the optimum, above the optimum range, then what is will be happen? Since a battery, when we are running the car, so it is in the char when we are running car, the battery discharges, and when we charge it, at that time also electron flows occurs, and in battery, inside the battery, electronic chemical reactions is also occurs. So when the battery here, in the second point, when the battery exposes at the high temperature, it's above 50 degrees centigrade, then what happens, the life cycle reduces from 60 to 70%, and this is very impact the great impact on the battery. Therefore, one I have seen in the research paper, a researcher have found that he did an experiment, and he found that at 45 degree lithium ion battery, FePO4, lithium ion battery at 45 degree, the life cycle was 3323. But when we increase the temperature of this battery up to 60 degree, then its life cycle reduces to the 1037, and which is very drastic. So we have to see, we have to overcome this problem, temperature problem, so that our electric vehicle performs a very efficient way and gives the maximum power output. So here, one temperature, if suppose we are not providing a battery thermal management system, so let's see what happens to the battery pack. So if suppose the temperature is we are increasing the temperature of the battery, we are not using any battery thermal. So when the temperature increases up to 80 degrees centigrade, so what happens here, the solid electrolyte layer, which separates anode and cathode, start decomposing, and this decomposing cause a problem. As we further increase the temperature, what happens, this starts decomposing, and there is an exothermal reaction which further adds the heat in within the cell and produces the gas. As we goes further from 120 to 30 degree, what happens, the electrolytes, anode and cathode, come in the contact, and the SCI layer melt down, and there will is cause a short circuit, because anode is a negative charge and cathode is a positive charge, and when these two comes in contact, definitely there will be a spark and a short circuit. If also further we are just increasing the temperature, what will happen in the cathode tube? It start decomposing and the oxygen start producing there, and above 150-degree, these oxygen basically react with the chemical reactions occur in the battery and make the system thermally unstable, and it sudden fire catches. So this is how in the graph shows that how SCI layer decompose and electrolyte breakdown, internal short circuit, and we attain the thermal runaway. So in electric vehicle, we do not want this to occur. And to overcome this, basically we need a battery thermal management system. So thermal runaway, the condition where the battery, the point where the battery catches fire, that condition is known as thermal runaway. So how this, due to the rapid growth of heat from one damaged cell to the another damaged cell, and the fire occurs in the battery, this condition causes thermal runaway. So when the at the point thermal runaway point basically takes only 10 seconds, and the amount of heat which has been generated when there is an explode in the battery is around 10 raised to power 7 watt per meter cube, which is very huge. So this figure shows that when, if we do not have a good heat dissipation, if we do not dissipate the heat which is produced in the battery, so what will happen, the temperature will rise, and which cause increase reaction rate, with chemical reaction rate will increase inside the battery pack, which cause heat generation and further cause thermal runaway. But if we dissipate the heat which greater than or equal to the heat generation, then our battery pack will be in the normal condition and it will be safe. So this is the main factor that we need to take while designing a battery pack or a battery thermal management system. So there Arrhenius law tells that when a battery temperature increases, when the chemical reaction takes place inside the battery, it changes exponentially with respect to the temperature. And when the exponentially changes occurs, definitely it takes less time and more heat and temperature generates. And one more thing, this law states that the hotspot area of the battery, when there the high temperature occurs, it start from the cathode tube, means it's start from the electrodes, anode or cathode. The heat generation or the temperature, it start high temperature starts from there only, and it's propagating everywhere throughout. So this uneven distribution of temperature in the battery cell cause life reduce in the life cycle and performance of the cell. Therefore, concept of battery thermal management system comes in the here. So we have to increase the battery life and overall performance. We need the battery thermal management system. So there are many types of battery thermal management system, thermal management system of battery pack introduced till now. So let us see. So battery thermal basically are classified into, broadly classified into 5 types. First is the power, according to the power consumption. Then according to the heat transfer medium, contact between the coolant and the battery surface based on the cell configuration, and also hybrid electric cooling system. So these are the broadly classified of BTMS. And let's start with the first part, that according to the power consumption, BTMS is divided into 2 parts: active cooling and passive cooling. So what does active cooling and passive cooling means here? So active cooling is the type of cooling method where basically we are using an external device such as fan, refrigeration, pump to actively dissipate the heat from the system, from the battery pack. Since battery is generating heat, so we are using an external device to remove the heat so that it can be in the optimum temperature range. But in passive cooling, what happens? We are going for a natural. We are not using any external device. We just try to dissipate the heat with the help of convection radiation, we uses the fin, this all systems arrangement, so that we do not gives extra amount of energy and remove the heat. So so now, according to the heat transfer medium, so this is the second broadly classified types of BTMS. So this is further classified into three parts, like air cooling, liquid cooling, and PCM cooling. So during designing of any battery thermal management system, air cooling, some are using air cooling for maintaining the battery temperature, some using liquid cooling, some using PCM cooling. So let's understand what is air cooling. So as name indicates, air cooling means it's a natural method. The air which is found around the surrounding, we uses that air and try to maintain the temperature, battery temperature within the optimum range. So how this is happened, that we use free or forced convection cooling. Suppose we make a fin and around the battery pack, and the air is just transport through that fin, and it takes the heat from the battery pack and just throw it outside. So these are the various EVs vehicle which are currently using an air cooling as their thermal management, like Honda Insight, Hyundai Ioniq, Nissan Leaf, Renault Zoe, Toyota Primes. These are the companies, electric vehicle companies are using, adopting this thermal management to maintain the battery temperature. So since this is an outline, that suppose we have made a battery pack. A battery pack consists of a number of batteries which might be arranged in the series parallel or series parallel. And in active, what we do, we basically add some fan and blowers in front of it, and this fan and blower, what it extract the heat from outside and send it to the battery pack. And this air extract the heat from the battery or cell and just release it to the outside. So this is how active air battery thermal cooling system works. Now in passive, what we do, this battery pack basically have fins over there, and these fins, the air just directly flows over the fins, and this fins, what it's do, it remove the heat from the battery and take it out. So this is how active and passive, basic concept of active and passive thermal management is. So there are several arrangements, different arrangements people are using to increase the efficiency of the air cooling. So this is one of the arrangement. This is a parallel type arrangement. There, this battery arrangement, like it is in series and parallel, the air is getting in from the down, and here it circulates, take away the heat from the cell, and just go out extract outside. So this is a kind of arrangement, it's one of the kind of arrangement. There are different types of arrangement, but air cooling have a limitations also. What it have a limited cooling capacity. When the load of the vehicle increases, the temperature distribution is very uneven. So, and also dust contamination also the one of the major issues. So to overcome this issue, there is another type of BTMS used, that is liquid cooled BTMS. So in this, what we do, we basically use liquid as a cooling medium for our battery thermal management system. So this liquid, how basically it works as a coolant, we are basically using a several components, such as one, we are using a coolant and a heat exchanger device, and plus a pump is used here to just to regulate, just to s- send the fluid within the channels what we have made, and just these fluids come out after taking the heat from the battery pack. And coolant is coolant is just sent into this channels. So the coolant, what it's do, it extract the heat from the battery pack and just say do extract the heat and just come out and just uh, so classification. So liquid cooling based cooling systems are classified into two parts: direct contact fluid and indirect contact fluid. When the battery this a battery cell when a battery cell is surface is directly contact with the fluid, like, so let's take a fluid of ethylene glycol as an example, then this is known as direct contact with the fluid, and the heat generated within the cell will directly sent to the this liquid. Second, when the battery is directly immersed to the liquid, there is, like, we made a liquid and we just directly immerse the battery in the cell without the flow of the fluid. We are the fluid is in idle state; it is not flowing. So in that case, battery gives the heat to the fluid, and this is how the temperature reduces under optimum temperature. Now, indirect contact is also there, in which basically we are using a channels or a discrete tubes. Within that tubes, the fluid is flowing, the coolant fluid is flowing, and the heat is extracted like this. So these are the one of the types of liquid cooling. So nowadays there are various types of coolant available in market, like oil, nanofluids, and glycerol, boiling liquids, liquid metal acetones. But in maximum EVs, water and ethylene glycol are used most as a coolant. So water alone is also not used, because uh, because the thermal conductivity of water, to increase the thermal conductivity, to increase the heat transfer rate, ethylene glycol is added to the water, which increase the ability of the coolant to extract the heat more comparative to the water alone. So since and also uh, this is good as a coolant because it have a lower viscosity and a higher thermal conductivity as well. So if we want to choose, suppose we want to choose a liquid cooling as a coolant, so what property does it should have? So the first property what it should have high thermal conductivity. This thermal conductivity is very much important because this only decides that how much amount of heat will be transferred from battery pack to the coolant. And it should also have a low viscosity, because if the viscosity will be high, then we requires large amount power of the pumps to just make it flow over the channel and all things. And it should also have high heat capacity to avoid shorts the short circuit to avoid short circuits. The liquid dielectric medium should be deionized, and it also should also be a corrosion resistant, inflammable, and it should be chemical stable, because if it will not be a chemically stable, it will react with the surface of the battery pack and might be corrode the surface of the battery pack. So many electric vehicles currently which is in market are using coolant liquid cooling also, like Tesla Model S, Model S, Model 3, and Toyota IQ, Volvo XC938, Ford Focus, Audi R8 e-tron. These are the vehicles which are using this liquid cooling BTMS in their vehicles. So liquid cooling also have a very good heating capacity, thermal conductivity, and they are non-inflammable, but they do have a disadvantage. And the disadvantage is the leakage. Leakage and initial cost is also very high of making, and maintain it requires more maintenance. And that's why now many researchers are focusing on PCM based cooling system. This is currently is not introduced in the vehicles, but it have a very various advantage over the, like, air cooling BTMS method. So how this phase change is advantage to us, that in this process basically the heat which is produced by the battery, the heat is transferred to the phase change material from it extracts large amount of heat during the phase change of the PCM material. So what happens? Let's suppose a battery of X temperature, it extract the heat up to the melting point of a phase change material like 40 degree. Let's suppose there's a 40 degree of the 40 degree is the melting point of one PCM material, and it also further extract the heat from the battery pack during the phase change, because here in latent heat of fusion at the same temperature from 40 to 40 degree, it requires the heat, and this is the extra heat which we can further extract at the same quantity from the battery pack. So this is an advantageous over air and liquid BTMS. So how does it work? What does it do? It absorb the heat from the battery pack, store and then release. So this is one of the very good method to extract the heat from the battery pack. Now, classifications of the PCM material. So PCM basically are available in a pure form, in a composite form, and also it is composite with the metal fins. So pure PCM basically it is like a paraffin wax, which have the low thermal conductivity comparative to the other. Therefore, we switch to the composite PCM, in which basically we add aluminum chips, nickel chips, copper chips to increase its thermal conductivity. Even expanded graphites, carbons, nanomaterials, graphenes, base materials are also used as a composite PCM to increase the thermal conductivity uh, of the PCM. So this is the basic classifications of PCM. Now PCM is also classified on the basis of material, like organic PCM is available, inorganic PCM, and eutectic PCM is also available. So in organic PCM, paraffin wax are used, and non-paraffin wax. Paraffin wax are used most since it have low cost, but the problem of paraffin wax is its conductivity is very less conductivity, which reduce the heat transfer rate. So to improve this, the conductivity of the paraffin wax, many other compound metals such as copper chips, aluminum chips, copper foams are introduced with this, and they combines and make a hybrid, or you can say the composite PCM, and to improve the conductivity of the PCM, and then we can use it for the proper heat transfer. So, what are the basic properties for the BTMS? The BTMS melting point should be between 35 to 60 degree, because since we know since we have to maintain the optimum temperature of the battery between 15 to 35 or 40 degree. So we need that the PCM should melt around this much so that it can extract large amount of heat from the battery pack. So it should also have high thermal conductivity and high specific heat. The latent heat also should be high. The more the latent heat, the more amount of heat it will be extracted from the battery pack. And also it should have low volume expansion, since if suppose if it have a high volume expansion, then what will happen? It will increase the area of the area of the thermal part where it has been installed, and it will cause various problems. So it should not be non-toxic, it should be inflammable, and it should not be corrosive also, because it will destroy the material of the sheet which we are using it. It should not be it should be non-explosive, chemically stable it should be. So after PCM, there is another technique of making battery pack under optimum condition is heat pipe. So heat pipe is basically, it is widely used in the recent years to control the temperature of the battery pack. So how does it works? Uh, in heat pipe, basically, what we do, there is a small amount of fluid which is filled inside the heat pipe and which act as a coolant. So what does it do? That from one section, the heat from the battery pack is entered into the heat pipe, and here basically it changes its phase, and it changes its phase and in the vapor form, and this vapor form just sent to the adiabatic channel, and then again from here there is a cotton wick surrounds that, which what it's do, it condensate the vapors which has been converted during the evaporator, and here is a heat sinks where the heat is extracted, and this condensed fluid is again circulated over here, and this cycles goes on, and this is how it extract the heat from the battery pack and save keep the battery pack under optimum condition. So this is the one of the type of battery pack. So now here now many research are going on hybrid BTMS, because this is because since we know that the applications are increasing, EVs are increasing day by day, the batteries pack is also capacity, battery pack and voltage is also increasing. So heat generation is also the major concern, which is since the size of the battery pack increase, the heat generation is also increased. So therefore, to improve the thermal conductivity of a material, as hybrid BTMS is also one of the alternative method which is been adopting now. So what does it do? What does it happens in this? Basically, we use all the medium which we have. We combines all the medium which we have studied just before, like air cooling, liquid cooling, and PCM cooling. So and heat pipe also. So in hybrid, what we do, we combine suppose air cooling and PCM with one. So this form a hybrid. We combine PCM with air, PCM with liquid, PCM with heat pipe. This combinations, when we combine in our design and make it improve the thermal conductivity, it improves the heating capacity, and also make the battery under the optimum range. So this is also one of the great innovation to maintain the battery under the optimum range. So there is a uh, comparison between these battery thermal management system. I have taken different types of cooling which we have studied till now, like air cooling, liquid cooling, uh, PCM cooling, heat pipe, hybrid BTMS. So there is a comparison done on the basis of aspects what I have taken here. The first is the cooling medium, that in air cooling we are using a natural air which is present in the environment. In liquid we are using various liquid coolant such as water, ethylene glycol, oils, nanofluids, like this as a cooling medium. Like in PCM, we are using various materials such as paraffin wax and paraffin wax with aluminum chips, copper chips, expanded graphite, carbon materials are also be used as a PCM material. Heat pipes we are using, and combination of liquid heat pipe and PCM are used in the hybrid system. So what are the basically mechanical mechanisms are used in this different process? So in air cooling, basically what we do, it's basically work on the principle of convection. So when the surrounding of the battery pack is heated and it approaches certain temperature, so the air which is flows over the passage of this battery pack, convectionally it extract the heat and remove from the zone and maintain the temperature. In liquid cooling, conduction process occurs because there is a direct or indirect contact. There is a sheet between the battery pack and the liquid, which with the help of conduction, this heat has been removed. In a phase change material, there is a phase change like sensible heating. Then, with the help of latent heat, also this more heat is extracted from the from the battery pack. And heat pipe also, there is a conduction process, we are conduction method we are introducing. And in hybrid, basically combination of all this, like convection, conduction, convection phase change, heat conduction, this process mechanism basically we took introduced in hybrid. So according to the thermal conductivity, air have a low thermal conductivity, because when at a various temperature, various load, this uneven distribution of temperature within the battery pack, and because of this low thermal conductivity, the efficiency is low comparative to the other cooling techniques. In liquid, the thermal conductivity, as per comparative to the other coolant technique, thermal conductivity is high. Therefore, many of the EVs are using liquid as their battery thermal management system. And in PCM, the thermal conductivity is it's basically variable, because it depends on the melting point of which material we are taking, around 40, 45, 60. The temperature changes the according to the material changes. We change we take different material. Their different material have different thermal conductivity. In heat pipe also, the thermal conductivity is very high, and in hybrid, when we use a combination, it changes accordingly. Heat capacity of air cooling is also very much low comparative to the other cooling techniques, and PCM and liquid have a very high heating capacity uh, comparative to the other. Now, if we differentiate on the basis of operating temperature range, then air cooling have a wide operating temperature range, and liquid cooling has a narrow. PCM has also narrow here means that we cannot go for a wide range in the temperature distributions. According to the efficiency, if we come to if we see, air cooling efficiency is comparatively low compared to the liquid PCM or heat pipe and others. So if we do the comparison of cost, then air cooling, since we find air in the surrounding, so its cost is low as compared to the liquid and other techniques, because in liquid we use coolant, which is quite costlier, and we have to make a channels and separate channels or separate arrangement we have to do. We use pumps, and this which increase the cost. And according to the maintenance point of view, liquid cooling and hybrid cooling have high maintenance compared to the air and PCM and heat heat pipe. Now, the second thing is that flexibility. Since we can in air cooling, there is a limited flexibility because the temperature distribution is uneven, so we cannot go for the wide changes in the air cooling compared to the other. And since if we go for the applications, if there is a small electric vehicle, so small size battery pack, we can go for air cooling. But if there is a big battery pack which is being used in the four wheelers, then we have to see liquid cooling, PCM cooling as the main target. So here one is the selection parameters, that how we can select a battery cooling, how we can design a battery cooling system with the if we have a battery pack, then how to initiate, how to what to do, what to take steps, how we can take a step to design a battery thermal for the battery pack. So let's just take one case, that for a battery pack, suppose we need a voltage this of 400 volt, and current total current or continuous current is around 20 ampere. So power which is being generated by a battery pack, so we have taken suppose 4 series, five parallel. This is just an example to understand. So the power actually the battery pack generate will be 400 volt or 40 volt. Just take 40 volt into 20 ampere, which is 800 watt of power a battery pack suppose it is generating. So this power basically of this power basically which a battery pack is generate is in the form of heat also, which we have to remove from the battery pack to maintain the temperature up to the optimum range. So how this, if suppose we are using a air cooling, if suppose we have this battery pack and we have arranged these cells like this, so we have to do trial and error. Suppose we have arranged a cell into series and parallel combination like this, and now we have aligned it in not staggered form, we have just aligned straight. Now if suppose we are using air as a medium, then how it will be efficient? If suppose in this arrangement only, in if we are using channel, so liquid cooling, and how we can make the channels, how we can flow the liquid within this battery pack, this is another types of approach. If suppose we are using a PCM on same arrangement, then how we can uh, place PCM between the cells, and also we can also go for the distance between the two cells, that how much it should be there, so that we can achieve accurate we can achieve higher efficient extraction from the battery pack, and keep the battery in the optimum range. So there are various arrangement we can do and analyze it, and we can see that which cooling technique is best. So for air cooling, for liquid cooling, for PCM cooling, for hybrid cooling, this we can uh, view previous papers, the researchers what they have used by analyzing their arrangements, how they made, they have used what technique, analyzing them and adding our approach into them, creating something new, how we can design the channels. This
Shubham, you are muted.
आपका एक दिन है तुम्हें मुझे बस
okay, suppose we have decided. So suppose we have decided, one second, that this arrangement will be good for us, and we also have made some chamber, and now we are using air as our coolant. So what we'll do, we will try to find out the flow rate of the fluid, how much the flow rate of the fluid will be, and how we will be able to find this flow rate. That this flow rate basically we will be able to find the total power or heat generated by the battery pack, which is equal to V by I. And after that, how this then after how we will be able to find the flow rate, this and the velocity, how at what velocity we have to send the air around the surface of the battery pack, and this is how works it. So this all analysis, this all calculation, after that we will import this, we will also make this model into a 3D software by using various softwares such as SolidWorks, CATIA, Creo, etc. We make this SolidWorks as per the dimensions of our. After making this 3D CAD model, we import this into the computational fluid dynamic. uh, we will applying CFD over it while using ANSYS software. In ANSYS Fluent, we import this geometry. So basically, we cannot make a prototype, or we cannot every arrangement we cannot make a model or prototype and do experiment, but it will be more costlier. So what we do, we basically use a software in which we applies all the boundary conditions, all the load conditions, all the models, and then we see the result that how using different battery techniques, battery coolant techniques, the result varies and which is good for us, and we will adopt that method for our uh, cooling system. So this is the process how basically we do by using various cooling techniques which we have covered till now. So this is was the overall introduction that what is BTMS, how we use, where what are the types of the BTMS. There are various types we have studied before, like air, liquid, PCM, hybrid, and how we can go for selection of the of a good cooling system, how we can and after doing a 3D modeling, we should import in CFD and analyze it and choose the best cooling techniques. So, thank you. Hello. So this is all from my side. If you have any questions, let's we can take it and discuss.
Hi, I don't know your name, but basically, based on the loss of energy, we are trying to take a which cooling method we have to use, right?
Yeah.
And even coefficient value matters when we are choosing the cooling system, and even compact or size of the thermal management which applies in the batteries. But when this come compatibility, how to choose, like I have a heavy battery for a four wheeler, and I want to make a efficient cooling system other than a phase changing, because phase changing will withstand in that time period. Once it is liquid, it is hard to, it need a some more time to cool down. So how to overcome that, in a which better place to use which cooling system in the four wheelers? Got my question?
Your question becomes answer to him. He is just trying to find out what you said, and now he will reply back. Okay. I think only system is that, yeah, liquid cooling is the best. Otherwise, air cooling, how can it can't be effective much. That but in car we have to have the air. There is no other
Uh,
system.
yes. I think Shubham, you are not audible. Wait a second, ma'am. I think he is facing some glitches.
Ah, I have already
Hello.
her question.
Hello.
Yes,
Yes, you are
Shubham.
audible, Shubham.
Hello. Now it's a 10. It's a, we are approaching to 6. Hello.
Please wait a second. He is joining from other device.
Hello, am I audible now?
Yes.
Yeah, Shubham.
Yes. Can you repeat the question?
What my question was like, if I want to use a cooling system in a four-wheeler, apart from a PCM, which will be a compatible other than a hair? You will say obviously a cooling system. Like how frequent if we use a cylindrical cells in spite of pouch or prismatic. This is what my question was.
Okay. We are using the prismatic cells because of the power density is very good in that prismatic cells, and in when we are using.
We lost you, Shubham. Your voice is not audible.
Basically, we are using prismatic cells in the four wheeler because of the high power density. We need a high acceleration power as well as a high energy density to cover the range anxiety, and that's why we are using prismatic cells in the BTS system. Battery thermal management system, which we are using for a four wheeler, it is a hybrid mode of active and passive cooling. In that active and passive cooling, we will find that PCM plus liquid or PCM plus air in the four wheeler.
Second question was how we calculate coefficient value based on like for example I have a 48 volt battery. I want to choose a cooling system. Generally I'm saying it is easy to go for a hair, but when
Okay.
we choose a cooling system by calculating a coefficient value, how we conclude that one, how we choose, I don't know how to calculate coefficient value, but coefficient value it is important when we are choosing the cooling system. That's what I heard from past classes.
Yeah, it's a mathematical expressions where we go for the efficiency test, where that how much efficiency level for the selection of cooling system, which are preferable for four wheeler, for two wheeler. But as a complete explanation, I can't say exact formula because I can't remember the exact formula now.
Okay. Are you guys are sharing this PPT or any chance?
Uh, you can connect our team, so they will guide us for the documents and all the PPTs.
What about certifications?
we will provide you the feedback link. In that link, you have to fill the all your details. By today, you will get the certificates.
Okay. Apart from other things, one small question like any plan for upcoming like coefficient value, energy loss, energy generation formulas like heat is equal to I square R, those explanation. Any plan for upcoming?
We will inform you when we are going to deliver about the complete technical terms. Okay.
Yeah.
We will
Thank
inform
you.
the prior with the mail.
Sure. No issues. Thank you so much.
Okay. So hope I'm going have cleared all of us the doubt. So today I'm going to wrap the session from my side.
Hello, sir. Hello.
Yes. Do you
Sir,
have
am I
any
audible?
doubts?
Yes, sir. I have one doubt. Sir, actually, I'm from Team Arawat, and we are participating in one of your competition like SIP e-bike challenge. You know, right?
Okay.
It's a e-bike challenge, e-bike manufacturing challenge. We participated in last year competition that held in January, like 2024. So, like, we use battery, but we have the constraint of cooling. Like, we have constraint for only air cooling. We can't use liquid cooling for our bike, right?
Yes.
So, is there any system that air cooling give? How can I build the system that will give more efficient work from liquid cooling और air cooling में से ऐसा like ऐसा हमने क्या किया था sir actually we only attached the one blower to the our chassis battery cabinet and the air flow went from one side to another side and that's how the battery get cool. But is
Bas-
there any different types of system we can use in air cooling and it will give the more efficient work?
Basically, in e-bikes and two-wheeler, we are using uh, air cooling passive systems of the BTMS because of the architecturing and the arrangements of space occupied for the appliances is very less. So we are preferring the passive system. Otherwise, if we are go for any liquid cooling or in-burst cooling, heat pipe systems, nowadays they are coming with the like in the two-wheeler, we mostly use the cylindrical cells. So in between of them, we are also going to assemble the heat pipes which will able to cover the all issues or we will get some more efficient output from this like we are having a liquid air cooling as well as heat pipes passive cooling system of heat pipe so which will all that material which we are using for the heat pipe is a aluminum material which is a heat absorber so somehow we are getting a good efficient on the e-bikes. Okay.
Okay, thank you, sir.
So hope I am clear the doubts of everyone. So today I'm going to end the session from my side. So concerned team, take the call.
Thanks for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company ISI India product and services that we offer in EV technology with small video. So kindly have a look on video.
అందరికీ నమస్కారం ఇప్పటి వరకు కాన్సన్ట్రేట్గా విన్నందుకు చాలా థ్యాంక్స్ ఫ్యాకల్టీ స్టూడెంట్స్కి ఇప్పుడు మా కంపెనీ గురించి చెప్పబోతున్నాము ఐఎస్ఐ ఇండియా ఇంపీరియల్ సొసైటీ ఆఫ్ ఇన్నోవేటివ్ ఇంజనీర్స్ సో మా కంపెనీ మెయిన్ మోటో ఏంటంటే ఈవీ స్కిల్ ట్రైనింగ్ స్టూడెంట్స్కి అలాగే వర్కింగ్ ప్రొఫెషనల్స్కి ఇండస్ట్రియల్ బేస్డ్ లెర్నింగ్ ఉంటుంది ఇక్కడ సో వీ హ్యావ్ ఎ సిఓఈస్ అండ్ ఎక్సెట్రా ఈ చిన్న వీడియో చూడండి ఇందులో మీకు మోర్ స్కిల్ కంటెంట్ దొరుకుతుంది.
As we are living in the fast-changing world of electric vehicles, ISI India is leading a tech organization, paving the way for innovation and revolutionizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta's University, Sharda Universities, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISI India is well positioned to develop the workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us inquiry through a QR code and displayed on your screen. Take your first step towards a more sustainable and exciting future. Thank you.
అందరికీ చాలా థ్యాంక్స్ విన్నందుకు, పేషెంట్గా విన్నందుకు. ఐఎస్ఐ అంటే ఏంటో తెలిసినట్టు ఉంది మీ అందరికీ. అండ్ ఐఎస్ఐ 14 COs ఉన్నాయి. యూ కెన్ ఈవీ స్కిల్ డెవలప్మెంట్కి, R&Dకి, ఇంటర్న్షిప్కి, డిజైనింగ్, హౌ టు డిజైన్ ది ఈవీ టెక్నాలజీ అండ్ ఎవ్రీథింగ్ మనం నేర్చుకోవచ్చు. అండ్ మీకు ఏమైనా క్వైరీస్ ఉన్నాయా, కోర్స్ గురించి క్వైరీస్ ఉన్నా, మీకు క్యూఆర్ కోడ్ డిస్ప్లే అయితే క్యూఆర్ కోడ్లో డిస్ప్లే అయిన క్యూఆర్ కోడ్లో మీరు క్వశ్చన్ పంపించండి. థ్యాంక్స్.
If anyone having doubt regarding the courses, please scan this QR code. Our executive will call you in 24 hours. Hope you will like this session. Please don't forget to fill the feedback form, and certificate will be shared by 9 PM today.